So in this video, we're going to look at one important aspect of inverses that was not covered in our previous learning objective. In the previous learning objective, we learned what an inverse was. It's just the reverse of the original. So if our original function, if I put in A and I got out B, my inverse, all right, first of all, that's the notation with the little -1. All right, my inverse function just does the opposite. I put in B and get out A. All right, so it just flips these inputs and outputs. All right, but the one important thing we didn't cover in that previous learning objective was that not every function has an inverse. All right, so let's see why that might be true. All right, so let's consider this table, which is about our function f of x. All right, the first question, we're going to find f inverse of 2. All right, we learned this in the previous video. Inverse just do it in the opposite, so our original function would go from the top row down, or my inverse is going to go from the bottom row up. So I'm going to start at 2, and I'm going to get out 0. And so f inverse of 2 is 0. All right, so nothing wrong there. F inverse of 3, so we'll do the same thing with 3. We'll look at 3, go to the top, and we get -1. There's nothing too crazy there. But if we look at our table, there's also another 3 here, and that would give me out 1. All right, so for one value of 3, I'd get out -1, and one value of 3, I'd get out 1. And really early on in the year, we talked about functions, and functions, when you plug something in, you should only get out one thing, not two things. All right, so us getting two things is bad. All right, so there's these functions that don't have an inverse, because when you try to go backwards, you'll get multiple things out. And when is this going to happen? This will happen whenever you have multiple of the same thing on the bottom of the table, which is representing your y values. So it's going to turn out that repeated y values are bad. All right, we don't want to have repeated y values. And that's exactly what this slide says. All right, for a function to have an inverse, it cannot have any repeats of its y values. All right, so no repeated y values, because then we can always go backwards from our original function. All right, any function that fits this criteria is known as one-to-one. All right, so this is a fancy way of saying it's going to have an inverse. It has no repeated y values. All right, so no repeated y values. All right, so here's an example. All right, we have a bunch of different graphs, and we know, does this function, or do any of these functions have an inverse? All right, so they're all functions, and we're asking ourselves, do they repeat y values at r? And if we look at this first one, does it repeat y values? And the answer is yes, because I could look at, for instance, these 3 points. All 3 of those points have the y value 0. All right, so there's multiple points that have the same y value, which means that one does not have an inverse. All right, what about the one on the bottom left? All right, are there any repeated y values? And if we look here and there, all right, both of those are y equals 2, and actually there's more of them. There's a bunch of values that have y equals 2, so this one also does not have an inverse. All right, let's move on to the right column. On the top right, if we have this point, that's the only point that has that y value, so that's good. Right, this one, I'm just going to pick some random ones that has the only y value. That's the only y value here, so this one should have an inverse. All right, no repeated y values. Any y value you pick, it only hits your graph once. What about here? I can pick this y value, only 1. That only happens once. This one only happens once. All right, so happening once for a y value is fine, as long as it doesn't happen multiple times. So this one also has an inverse. All right, and looking at this picture with these little dashed lines I drew, it might make you think of something we learned before. When we were talking about functions, we had the horizontal line test, so we drew a bunch of horizontal lines. And as long as those only hit the graph once, it was a function. So now for a one-to-one function, we do the same thing, but it's called the horizontal line test. All right, we draw these horizontal lines, and as long as those only hit your graph once, then it has an inverse. All right, so that's exactly what this is saying. All right, for a function, we did the vertical line test. All right, we drew vertical lines. If our graph hit a vertical line twice, it was not a function. If it only hit the vertical lines once, then it was a function. But now we're going to have the horizontal line test. So we're going to draw a bunch of horizontal lines. And if our graph hits these horizontal lines more than once, like that, right, hitting it more than once, that is not have an inverse. But as long as it hits the horizontal lines only once, then it does have an inverse. So here's an example for you to try on your own. All right, determining if this graph has an inverse. And the answer you should get is no. All right, does not have an inverse. Let's see why. So first, let's just check, is it a function? Because it definitely can't have an inverse if it's not a function. So function, we do the vertical line test. I draw vertical lines going straight up and down. As long as these only hit my graph once, then I'm good. So is this a function? Yes, it's a function. All right, so that's good. All right, is it 1 to 1? All right, so now we know it's a function. All right, is it 1 to 1? Because if it's 1 to 1, then it has an inverse. 1 to 1, now we do the horizontal line test. So we draw a bunch of horizontal lines. Right. And if that hits your graph more than once, it's not a 1 to 1 function. All right, so we have this horizontal line, which hits our graph 4 times, which means it's not 1 to 1, which means no, it doesn't have an inverse. All right, so the horizontal line test is going to tell you if it has an inverse. All right, so for this concept, you're going to do problems on Delta Math. They're going to give you a graph, and you have to do 2 steps. All right, first of all, you have to determine if it's a function. So you're going to do the vertical line test, and then you're going to determine if it's a 1 to 1 function. Do the horizontal line test. So you're just doing the 2 different line tests to determine if it's a function and if it has an inverse.